In its most general form, the quadratic equation is simply y equals x squared. So that is our basic standard quadratic equation that we use as a reference whenever we're talking about it. Your standard linear equation would be y equals x. In terms of quadratics, it's y equals x squared. Here's a table of values for y equals x squared, where I've selected x from -3 to +3. It goes 9, 4, 1, 0, 1, 4, 9. You will often see this repeating set of values. Not every time, depending on the specific values you pick and which values you're working with. But in a general case, the repeating pattern happens because the graph goes down then back up. So it goes down then back up in this case with a graph that's opening up. We have the standard graph here. Point at 0, 1 and -1, 2 at 2 and 4, 2 and 4, and then at 3, 9, -3 and 9. Notice they're all symmetrical about the vertex. The direction of opening of this graph is up, and notice that symmetrical standing comes with this kind of pattern. If I go over 1 this way, I go up 1 this way. If I go over 1 this way, I go up 1. Over 1, up 1, over 1, up 3, over 1, up 5. It works either way. So whatever pattern of steps you take going left, it's the same going right. And vice versa. Now, if we tweak the formula a little bit, we throw an a value in front of the x. So some sort of number in front of the x. There's two possible transformations or changes that it will make. So we have a couple examples here. One, if we just have y equals -x squared. Note that this is different than y equals -x in brackets squared. There's no brackets, so it's treated as x squared, put a negative sign in front of it. So it's two things. Square the x value and then put the negative sign in front of it. So when I filled in the table for this, I had -3. So it's -3 squared, which is 9. Put a negative sign in front. Next was -2 squared, which is 4. Put a negative sign in front. -1 squared is 1. Put a negative sign in front. 0 squared is 0. Even with a negative, it's still 0. Same thing here. 1 squared is 1. -1 with a negative sign. 2 squared is 4. Put the negative sign. 3 squared is -9 with the negative sign there. So each time we're adding the negative sign. If you notice, compared to the original values, they're the same values, just the y's are all negative. If I was to graph this, I got 0, 0, and then I usually, if I know the vertex, I just work my way out from the vertex because it's symmetrical. So I have -1 and -1. Then I have -4 and 4, and then -9 and 9. So it's sometimes easy to graph that way. You might not always be able to do that. Not every graph will be looking perfectly symmetrical depending on where you're starting, depending on your values. However, in this case it does, and because I have that, I use that to my advantage. So here is the negative value of a. So if there's a negative sign on a, you see you get the same graph. Zoom out a little bit here. You get the same graph as y equals x squared, except it's flipped upside down. This one's opening up. This one's opening down. Now, if we instead change the a to a number different than 1, so y equals x squared is just y equals 1x squared. If we use 1/2, all these values are squared. So these are all the x squareds. We just take the x squareds and we divide them by 2 or multiply them by 1/2. So I have -3 squared, which is 9. Half of that is 4.5. -2 squared is 4. Half of that is 2. So on down the list. If I was to graph these values here, I'm going to get 0 and 0, 1 and 0.5, and -1 and 0.5. -2 and 2, +2 and 2, 3 and 4.5. And then 4, if I don't have it here, but 4 would be 4 squared, which is 16, and half of that, half of 16 is going to be 8. So I can put that on just because we can easily do that calculation. So if I'm to connect those dots, get a graph looking something like this. You notice the graph looks a little wider. So the graph is widened out. What's happened is we've compressed it. If we were to push down the graph here, if we were to push down this red line, what would happen is it would start to, has to go somewhere. You can't just crumple it. So it starts to, if it goes down, it starts to go out. And so this is pushing the line down. If you were to grab these points and push them down, they start stretching out. So the point at 1, cut in half. The point at 4, cut in half. The point at 9 went halfway. The point at 16, which is somewhere way above here, went down. So we've cut the graph in half. This is, we'll call this equation 1 here. And then we'll do this other one below, 2x squared. We'll call that equation 2. So what have I done in each time here? I've taken my -3, squared it for 9, multiplied it by 2. So I got plus 18, and then worked my way down. -2 squared was 4 times 2 is 8, so on and so forth down the row. If I was to plot those points, what I would get is, again, a 0 vertex, and then I have 1 and 2, 2 and 8, and that's all that's going to fit on this graph here. So I have this shape here for my parabola. Line's a little squiggly, but we have this interior parabola number 2. So what's happened is we've narrowed it, or technically it looks narrow, but what we've done actually is taken these points. If you were to grab these 2 points and stretch them out, then the lines would get tighter together and we'd make a narrower looking parabola. But we've stretched the parabola here. So A, if it's negative, is going to flip the parabola upside down. If it's a value between 0 and 1, it's going to widen the parabola or compress it. And if it's greater than 1, it's going to stretch the parabola or narrow it. Now, if we, instead of A, use a value like k and add it to x squared, like I have here, I have x squared plus 2, and then I have an x squared minus 2. What I have is -3 squared, which is 9, plus 2 is 11. -2 squared is 4, plus 2 is 6. -1 squared is 1, plus 2 is 3. 0 squared is 0, plus 2 is 2. And then I continue down. So if I was to graph this set in comparison to the y equals x squared, which I have graphed here, then I have 0 and 2. I have 1 and 3. I have 2 and 6. And I have 3s and 11, +3 and -3. So here I have now taken the graph and shifted every point up by 2. So the 0's gone up 2, the 1's gone up 2, the points at 2 went up 2, the point from 3 went up. Oh, that was 12. Sorry, it should have been 11 down here. Went a little too far up. There we go. So, and then those went up 2 and up 2. So everything just shifted up 2. When we have the -2, it's the same idea. -3 squared is 9. Subtract 2 is 7. 2 squared is 4. Subtract 2 is 2. -1 squared is 1. Subtract 2 is -1, and so on. So we have our points here, at -2, and then our -1s, and then our 2s, and then our 7s. And again, our graph has taken each point and shifted it down this time instead of up, but down 2. So every point has gone down 2 values. And everything is shifted down 2. And we have our parabola. So when we add or subtract onto the x squared portion, adding makes it go up that much. Subtracting shifts everything down that much. Finally, what if we add something to the x before we square it? So here we have x squared plus an h value. So if we put an h value in there, what happens is we have a -2 in here, we got a +2 in here. So as I do that, 3 squared, or sorry, -3 minus 2 is -5. Square -5, I get 25. -2 minus 2 is -4, squared is 16. -1 minus 2 is -3, squared is 9, and so on. So if I go to graph that now, I'll put the points that I can fit on my graph. Can't fit a -3, can't fit a -2. I can fit the -1, -1 and 9, 0 and 4, 1 and 1, 2 and 0, 3 and 1. And you can see what's happening here is the graph is coming down and starting the parabola again. I can tell you, because I've now found my vertex right here at 2, that this will be a mirror image over here. This will be a mirror image over here. There's my parabola. Shifted over to the positive side by 2. Every point has shifted over by 2. So everything's shifting over by 2 when I'm subtracting 2. When I add 2, I have -3 plus 2, which is -1. -1 squared is 1. -2 plus 2 is 0. 0 squared is 0. -1 plus 2 is 1. Squared is 1, so on and so forth. So when I get all those points, what I have is something looking like this. So now I have this other graph where everything is shifted over to the other way. So I shifted over 2, shifted over 2, shifted over 2, shifted over 2, or sorry, shifted over 2, shifted over 2. So everything is shifting over 2 to the left. So when there's a minus, it shifts to the right. When there's a plus, it's shifting to the left. We'll take a look at more of this in more formalized manner in the next section.